Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving longest unequal adjacent groups, subsequence 2. So we are given a string array words and an array groups, and both will have the same length. And we need to know that the Hamming distance between two strings of equal length is the number of positions at which the corresponding characters are different. And we need to select the longest subsequence from the array of words that, as we see here, the Hamming distance between them is 1. So that's the first condition, and the second condition is that their corresponding value in groups are unequal. So they don't have to be different by 1, but they just have to be unequal. And then we want to return a string array that satisfies that subsequence. If there are multiple ways, then we can return any of them. So if you look at this example, we can return Bab and Cab because their Hamming distance is 1 because only C and B is different here, and their value in groups are different. So another valid array that we can return is Bab and Dab, as we see right here. So that will be our result. So now that we have seen some examples, let's get to how we can solve this problem. So one way that we can solve this problem is we can use dp to keep track of the sequence, and we can set up this prev array, and each index in prev will tell you the previous index of the sequence, and largest variable will represent the largest index of the largest sequence. So we will look through the words array, and at each index we will have to look at every string to the previous and see if it can cause a sequence, and if it does, we will edit dp prev and largest, and then after we have figured out the dp array, we can use these array and the prev array to add elements to the result, and then we can return the resulting array. So let's go over this example real quick. So first we realize a, b, and aa are different by one letter, 1 and 2 are different, and we can add 1 to 2 here and set the previous index to 0. So now we look next, A, B, and AC, they are different by 1 character. 1 and 3 are unequal, so we can also change this to 2 as the second sequence and the previous index as 0. But we see here, AA and AC also different by 1 character. 2 and 3 are unequal, so we can just continue the sequence from here instead and realize that it will be larger, so we can edit that. So the previous index would be 1, and at 1 the previous would be 0. And then we also need to change the largest index to 2. That's the largest index in the current sequence. So now we look next, A, B, and BB are different by 1, so we can increase it. And we look next, AA and BB are different by 2 letters, so the Hamming distance is now 1, so we just look next. And same for AC and BB, is different by more than 1 character. So now we look at BC. BC and AB, again, the Hamming distance is not equal to 1, so just skip it. Same for AA and BC. And for AA and BC, the Hamming distance between the two is 1. 3 and 5 are unequal, so we can continue from the sequence 3, which will be 4. And the previous here will be index 2. Now we look at BB and BC. The Hamming distance is 1, but if we continue the sequence from here, it's actually smaller than right here, so we can just keep 4. And now that we have come to the end, we can add to result. So we will start with the largest index, which is BC. And then at 4, the previous is 2, so we will add AC. At 2, the previous is 1, so we will add AA. And at 1, the previous is 0, so we will add AB. And at 0 is -1. So as soon as we see -1, then we can just reverse the array and return it. So this will be what we return. And the time complexity would be O of n squared times L, where n is the number of elements in words, and L will be the length of each string. Because when we compare the string on Hamming distance, it will take L time since we have to look at each character, and it's n squared because we will have to look at each word in words, and at each word we have to compare to all the previous, so that's why it's n squared. And the space complexity would be O of n because dp and prev will depend on the number of elements in words. So now let's get to the coding part. So first, we will define the function for checking if the Hamming distance is equal to 1. So if the two strings have different length, then return false right away, because that for sure will not have a Hamming distance of 1. Otherwise, we will initialize difference to 0, and we will look through string 1 and string 2. So for C1, C2 in zip of S1 and S2. If we find any characters different, increase the difference by 1. However, if the difference surpasses 1, then we can return false. Otherwise, if we have finished looping, we can return true. So now we can get to the main function. We will first initialize dp as 1 times length of groups. And then now we will initialize previous, so pre -1 times length of groups. And we'll initialize the largest variable as 0. And then we will look at for I in range 1 to length of groups. And for j in range I, so j will be all the previous words before I. And we will check if words of I and words of j has a Hamming distance of 1. And if that is the case, then we want to make sure the dp of the previous element is greater than or equal to the current one. And then we will check if their groups values are different. If all these three are satisfied, then we can edit the dp and the prev. So dp of I will now be dp of j plus 1. So that will continue the sequence. And the previous of I will now be j. So that will let us know what the previous element is. And if dp of I is greater than the dp of largest, then we need to edit the largest index. So largest will be equal to I. And now we will initialize the result as an empty array and set the index to largest. And while index is not -1, so greater than or equal to 0, result.append words of index. And index will set to the previous, and then we will keep looking through the while loop. And when we are done, we will reverse the resulting array and then return the resulting array. Let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comments section, and I hope to see you all again soon.